So, in the last class we were just having a brief introduction to semiconductors. Today we shall see the classification of semiconductors as intrinsic and extrinsic semiconductors. So, as I told you, in case of intrinsic semiconductors, we have a tetrahedral structure of silicon, where each silicon atom is bonded to 4 other silicon atoms in space, and each silicon atom is sp3 hybridized. So, the silicon atoms basically have 4 sp3 hybridized orbitals oriented tetrahedrali in space. It is somewhat like this, such that this Si bond angle is 109 degree 28 minutes. Now, under normal conditions at absolute 0, all these electrons are located in the respective position in the tetrahedral structure at any temperature of the absolute 0. These electrons, some of these electrons get sufficient energy as to dislodge from their original positions in the covalent bonds and move around as free electrons in the material. Now, this conductivity of this silicon crystal can be sufficiently increased by doping the silicon crystal with impurities which are which can belong to group 3 or group 5 of the periodic table. So, let us first study what happens if we dope a silicon crystal with some group 3 impurity. So, for this purpose we diffuse some activated boron into the silicon crystal, and boron is a group 3 element. So, which means it has got 3 electrons in its outermost shell. So, these 3 electrons can form 3 covalent bonds with 3 silicon atoms, but since it does not have a 4th electron in its outermost shell, so the 4th bond between boron and silicon is provided with some vacant site. So, now what happens because of this vacant site? This bond will have a tendency of gathering some electron from surrounding and putting it over there, so as to form this complete the covalent bond. So, the amount of energy needed to transfer an electron from neighboring place to this vacant site is considerably less than for a normal silicon bond. So, if you see the band energy band structure, then this is the conduction band, this is the valence band. So, since a vacant site is over here, therefore, I can say that it is equivalent to the presence of a hole. So, as you transfer an electron to this position, you are basically transferring a hole from this place in the bond to the free space as if. So, which means that you are releasing a hole. So, so if this is the Fermi energy level, then these atoms will try to give up some small amount of energy and come back to the valence band as holes. So, in case of this type of extrinsic semiconductors, which are in which the silicon is being doped with a group 3 element, such as typical ones are boron, then gallium, aluminium, etc. These are the so, since these impurities have a tendency of accepting an electron, they are called acceptor impurities. Now, when this atoms they emit the some energy and come back to the valence band and some holes are formed in the structure. These holes are capable of conduction. The other is the case in which the silicon atom is being doped with group 5 elements, such as phosphorus, arsenic, antimony, etc. Phosphorus is most commonly used. So, these elements have got 5 electrons in their outermost shell, of which 4 gets bonded to 4 silicon atoms, and the fifth atom is loosely bound to the phosphorus atom. So, you need very little energy to dislodge this electron out of the phosphorus atom and release it as free electron. So, in this type of semiconductors, you will find that the Fermi energy level is quite close to the conduction band, which means you need a little bit of energy to promote these electrons to the conduction band and release them as free electrons. So, once these electrons are released as free electrons, they can move about freely in the semiconductors. So, as you can see, in one type of semiconductors, you are basically doping with group 3 elements, which are called acceptor impurities. You call, since you have abundance of holes in these semiconductors, they are called p type semiconductors. The other type of semiconductors are those where you diffuse group 5 elements such as phosphorus, arsenic, antimony into it, where you have abundance of electrons. They are called n type semiconductors.